morning and welcome to our next maths lesson. Now you'll see that this week we are moving on to looking at percentages. We were looking at decimals last week and they nicely flow into percentages, so that's what we're starting to look at this week. So please will you pause the video now and copy down the date and LO into your maths books. Okay, so you should have given yourself enough time to copy down both the date and LO there. So let's start this lesson by looking at a review at what we did last week. So question number 1 says, what is the width of one paving slab? Now if we look at the diagram drawn here, we can see that we have a pathway here. Now a paving slab is just basically a stone that creates a path. Okay, so they've given us the width of all of these paving slabs and they tell us that all of them together is equal to 4.24. What the question wants you to figure out is what is the width of one of these paving slabs. Number 2 says, how many slabs would Toshi need to make a path that is at least 10 meters long? So you can only work out the answer to question number 2 once you have worked out the answer to question number 1. Okay, pause the video now and have a go at both of these questions, please. Okay, so you should have given yourself enough time to have a go at both of these questions. So let's have a look at how we can answer question number 1. Now with question number 1, in a lot of word problems that involve fractions, decimals or percentages, it's really good to try and use a bar model, okay, to represent exactly what we are given and exactly what we are trying to figure out. So in this question, they have told us the total amount. They have told us the total width, and they have told us that the total width is 4.24 meters. Now it's important to recognise the unit of measure because your answer will then be in that unit of measure. Now the next thing we can do is we know all of these make up 4.24, but actually how many of them are there? So 1, 2, 3, 4, 5, 6, 7, 8. And we can see that all 8 of these are completely equal. So underneath here I could be drawing 1, 2, 3, 4, 5, 6, 7, 8. Now I know these are not equal, it's difficult to draw that, but we understand from looking at the picture that they are equal. So we now know that there are 8 paving slabs which make up this 4.24 meters. So what calculation do you think we'll need to do to work out what just one of these equals? So all 8 make 4.24. We know they are all equal. So how can we work out what one of them equals? So the calculation we should be doing is 4.24 meters divided by 8. Now if you didn't get that, if you didn't understand that was the calculation that you had to do, please pause the video now and have a go at calculating your answer to that, because that is something we looked at last week. 4.24 divided by 8. Okay, let's look at what the answers should have been then. So for number 1, when we did 4.24 divided by 8, we should have got to 0.53 meters. Now some of you might have converted that into centimeters and therefore would have written 53 centimeters. However, both of these answers are correct. Now number 2 is a little bit trickier. And it says how many slabs would Toshi need to make a path that is at least 10 meters long? Now we know that one slab is 0.53 and we're looking to get to 10. And this is where if you can recognise patterns, then you can do this question a lot easier. So if you look at what I've done here, I've recognised that 2 of the slabs then, if one slab is 0.53 meters, 2 slabs would be 1.06 meters. And therefore I've realised actually if I want to get to 10 meters, I've got to have 10 lots of this to get to 10.6 meters. Now I also know that 2 slabs times by 10 would be 20 slabs. So I've put my answer as 20 slabs here. Can anyone spot a mistake that I've made here? Should my answer be 20 slabs? Have a think. And if you look carefully, I can see that one slab is 0.53 meters. So I could actually take off a slab here, take off a 0.53, and my answer would still be above the 10 meters. And therefore my answer should not be 20 slabs. And this is a really easy mistake to make, but my answer should not be 20 slabs. My answer should be 19 slabs. Now, if I wanted to do it using a diagram, I know 1 is 0.353, I could put another one on, I could put another one on, and I could keep adding 0.53 each time until I got too much, until I got above 10. And then I would have got my answer. And both ways I'd have got 19. Now my way, recognising links between numbers, is a much quicker way of doing that. But if you need to draw the diagram and add them up, 0.53 add 0.53 add 0.53, then do that, okay? Either way you would have got the right answer. Right, let's move on to today's session now then. So the first question I want you to think about, and I just want you to think about this in your heads, is what does percent mean? We've looked at percent a lot and we've used this phrase quite a lot. Percent means something. Can you remember what it is? So percent means out of 100. That's a really key thing that we need to remember for this week and for next week, that percent means out of 100. If you remember that, you're off to a very good start, but it's a really crucial point. So if we write the symbol percent, which we now know means out of 100, as a fraction, we could write it like this. So whenever we see a percent sign, we can turn it into a fraction by putting out of 100. Okay? Really important that we remember these two things, that percent means out of 100, and if we want to convert the percentage to a fraction, because we know percent is out of 100, we can write out of 100. Okay, let's look at why that's so important. So because I know that now, can I write the following percentages as fractions? Now, let's have a look. 75% I now know means 75 out of 100. So 75% as a fraction means 75 out of 100. Now that's really, really easy. And that there straight away you've converted it, and it's really quite simple. Now if you wanted to simplify that, you could simplify it down to 3/4 by dividing the top and the bottom by 25, and that would still be the correct answer. But really all you need to know is 75% is equal to 75 out of 100. Same with 39%, let's have a look at that. I know percent means out of 100, so I can read this as 39%, but I could also read it as 39 out of 100. And if I read it in that way, I now can see that it's really quick, really simple to convert my percentage into a fraction. So 39%, I can say 39 out of 100, and as a fraction I can see 39 out of 100. Okay, so I want you to have a go, please, at these four. Can you convert these four percentages into a fraction, please? Off you go. So you should have given yourself enough time to answer those there. So let's have a look at what the answers are. These are quite simple, so I expect you to be getting these correct. So we can see 55% is the same as 55 out of 100. 23% is the same as 23 out of 100. 11% is the same as 11 out of 100. And 83% equals 83 out of 100. Now you may have simplified 55 out of 100 to 11/20. That would also be the correct answer. But you can see how quick and how easy it is to convert between our percentage and a fraction if we just remember that the percent sign means out of 100. So what about if we go the other way then? Can we write these fractions as percentages? So here it says 44 hundredths, which we could write as 44 out of 100. And we know that when we hear out of 100, that means percent, so we just literally write 44%. Let's look at number 2, 21 out of 100. I can write, it's a vertical fraction, 21 out of 100. And when I hear the words out of 100, I know that also means percent, so I can just write 21%. As simple as that. If the denominator of a fraction is 100, it really is that simple to convert it to a percentage. So now I want you to have a go, please, at the next four. So you've got 13 out of 100, 37 out of 100, 83 hundredths and 74 hundredths. Pause the video now, please, and have a go at those four. Okay, so you should have given yourself enough time there to have a go at those four questions. Let's have a look at what the answers should have been. So 13 hundredths should have been 13%, because we know hundredths means out of 100, and we know percent means out of 100, so we can see they are exactly the same thing. And remember, that is what the equal sign means. It just means is the same as. 37 hundredths is the same as 37%. 83 hundredths is the same as 83%, 74 hundredths is the same as 74%. So please mark your work there. Again, all this comes back to is just knowing that percent means out of 100, and knowing that if we hear the words out of 100, we can write it as a fraction. So, what if the denominator is not 100 then? This is where we get a little bit trickier, because we can see in this fraction here, my denominator is not 100. My denominator is 50. However, when we did our fractions unit just before we broke up at Christmas, we looked at how to find something called equivalent fractions. So basically, fractions that have a different denominator, which are exactly the same value, they're equal to each other. So what is our saying? Whatever you do to the something, you do to the top. And we know our saying, whatever you do to the bottom, you do to the top. So let's have a look. I know when I wanted to convert this fraction to a percentage, I want my denominator to be 100. Because I know percent means out of 100. So if I can ever get my denominator to be equal to 100, then the question is very, very simple, as we showed on the previous slide. So let's have a look. Is there a way I can get from 50 to 100? Well, you should be able to see that if I just multiply that by 2, 50 times by 2, it does equal 100. And our saying is, whatever we do to the bottom, we do to the top. So we now have to times the top by 2. 31 times by 2 is 62. And now that is very simple, because 62 out of 100 is the same as 62 out of 100, or 62%. So now I know that 31 fiftieths is just equal to 62%. Let's have a look at another one. So again, we need to remember our saying here, because our denominator is not 100 this time, so it's got an extra step in. This time it is 10. We remember our saying, whatever we do to the bottom, we do to the top. That's right. So 7/10, remember, percent is the same as out of 100. So we're looking to get a denominator of 100 to make our question easier. So let's have a look. Can I go from 10 to 100? Yes, I can. We should all be able to see that 10 multiplied by 10 equals 100. Our saying is whatever we do to the bottom, we do to the top. So 7 multiplied by 10 would give us 70. And I now can see that 70 out of 100 is exactly the same as 70%. And now I can just put my answer in there. 7/10 is equal to, or is the same as, 70%. So now it's your turn. Can you have a go at these, please? So you've got 5 questions, 3/5, 2/50, 12/25, 3/10, and 17/20. And I want you to convert them into percentages. Now I've put a few tips on the side here. The first one, remember, percent means out of 100. So we want our denominator to always get to 100. The next one, can we find an equivalent fraction with a denominator of 100? We looked at that before. And the third, remember, whatever we do to the bottom, we do to the top. Now we'll just get started on question number 1, just to make sure people have an example. We have 3/5 here, and we want to convert that to 100, to a denominator of 100. Why do we want to do that? Because we know percent means out of 100. So now we look at what number we started with. We started with 3/5. How do we go from 5 to 100 then? You should be able to see that we multiply by 20. Our saying now, whatever we do to the bottom, we do to the top. 3 times by 20 would give me 60. And therefore my answer, because 60 out of 100 is just the same as 60%. So 3/5 is equivalent to 60%. So I want you to have a go at number 2, 3, 4, and 5. So pause the video here. Okay, so you should have given yourself enough time to answer those 4 questions. Let's have a look at what the answers should have been. So we should have converted from 2/50 to 4/100 by noticing that 50 times 2 is 100, so that 2 times 2 is 4. Then we should be able to see that 4 over 100 is the same as 4%. Number 3, we should have times the denominator by 4 to get to 100. So therefore we times the numerator by 4 to get to 48. And there 48 over 100 is the same as 48%. The fourth one, we've looked at tenths before, so you should have known that to get from tenths to hundredths, you multiply by 10, and therefore we multiply our numerator by 10 to get to 30, and therefore we get 30%. And the final one, we've looked at 20ths before as well. To get from 20ths to 100ths, we times our denominator by 4. Whatever we do to the bottom, we do to the top. Therefore we times 17 by 5. Therefore we times 17 by 5, and we get to 85 over 100, which we can simply convert to 85%. So mark your work here, please. So let's carry on looking now. What about, and this is the last thing we're going to look at today, what about if the denominator doesn't easily convert to 100? So let's have a look at this one here, 24 30ths. Now, I can't take 24 30ths and convert that 30 as a denominator to a denominator of 100 straight away, because I can't times 30 by anything to get to 100. So therefore I'm going to have to do an extra step here. Okay, so let's have a look at this, and I've put some tips down the side here. So think, what number is a factor of both 30 and 100? If we can't see a factor of 30 and 100, we can just simplify using our 4 questions. We reminded ourselves of those 4 questions last week. I will go through them again now. So the first question, do they both go into the 10 times table? The second question, do they both go into the 5 times table? The third question, do they go into the 2 times table? And the fourth and final question, do they go into any other times table? So let's have a look then. 24 30ths, do they both go into the 10 times table? Well, 30 does. Does 24? No, it doesn't. Let's look at the 5 times table then. Again, 30 goes into the 5 times table. Does 24? No, it doesn't. Let's look at the 2 times table then. Oh, 30 does go into the 2 times table again, and this time 24 also goes into the 2 times table. So if I'm looking to simplify this fraction, because we remember the same, whatever we do to the bottom, we do to the top, we have to be fair to both the denominator and numerator. We would divide both by 2. 24 divided by 2 is 12, and 30 divided by 2 is 15. Now I look again, can I go from 15 to 100? Well, no, I can't. So now I need to simplify further. So I can say, do they both go into the 10 times table? This time neither of them do. Do they go into the 5 times table? Well, 15 does, 12 doesn't. Do they go into the 2 times table? This time 12 does, but 15 doesn't. And number 4, do they go into any other times table? And I can see, if I look carefully, they both go into the 3 times table. 12 divided by 3 is 4, 15 divided by 3 is 5. And now I look and I can see here, actually 5, I can go from 5 to 100. So here, 5 times by what gives us 100? Well, times by 20. I was saying, whatever we do to the bottom, we do to the top. 4 times by 20 then is 80 out of 100. So now I can see that 24 30ths is the same as 80 out of 100. Now I've got the denominator of 100, which I wanted. It is really quick and really simple to convert that into a percentage. And I can see that 24 30ths is the same as 80%. Now some of you might have looked at 24 30ths and recognised a factor of 30 and a factor of 100. So a number that goes into both 30 and 100 is 10. And you might have gone straight and simplified to tenths by dividing by 3. And you'd have got 8 tenths, because you divide the denominator by 3 and the numerator by 3. Again, now you can go straight to the denominator of 100 by timesing by 10, and you can see that you would have got the same answer still. So if you can see a factor, use that, but if you can't, simplify using the 4 questions which we always use when simplifying. So let's look at the next one, 10 40ths. Okay, so again here we would think, is there a factor? So some of you might be able to spot that factor, so then do that, because that's a quicker way. But let's look at if we can't see the factor. If we can't see the factor, we simplify, because I can see that 10 40ths, I cannot go straight to 100ths, because 40 does not times by anything to give me an answer of 100. So I'm going to have to simplify here. So I get my fraction, 10 40ths, and I go through those 4 questions again. If you struggle to remember the 4 questions. I suggest you write them down. The first question is, do they both go into the 10 times table? The second, do they both go into the 5 times table? The third, do both the numerator and denominator go into the 2 times table? And the last one, do the numerator and denominator go into any other times table? So let's have a look here. Do they both go into the 10 times table? 10 does, because 10 times 1 is 10. And 40 does, because 10 times 4 is 40. So I can see that I can divide both the top and the bottom by 10. And that's really important, because I was saying is, whatever we do to the bottom, we do to the top. Now I check again. Can I go from 4 to 100? And yes, I can. How can I go from 4 to 100? Because I can multiply by 25. Whatever I do to the top, I do to the bottom, or whatever I do to the bottom, I do to the top. So I need to times the top by 25 now. 1 times by 25 is 25. So I now know that 10 40ths is the same as 25 over 100. And now that I've once again got that denominator of 100, I can quickly convert that into a percentage, and I can give it as 25%. So now I know that 10 40ths is the same as 25%. And the final one we're going to look at is this one. So 18 45ths. Again, I can see that 45ths cannot go straight to 100 as a denominator. It doesn't times by anything, because 45 times by 2 is 90. It doesn't take me to that 100. Again, some of you might be able to spot a factor here of both, but we're going to look at those who struggle to see that factor and what we would then do. So 18 45ths, okay, we are now going to simplify. Remember those 4 questions. The first one, do they both go into the 10 times table? And this time neither of them do. Do they both go into the 5 times table? Well, 45 does, but 18 doesn't. Do they both go into the 2 times table? This time 18 does, but 45 doesn't. So do they go into any other times table? And if I look really carefully, I can see they both go into the 3 times table. 18 divided by 3 is 6, and 45 divided by 3 is 15. Again now, I look, can I go from 15 to 100? No, I can't. So I look at simplifying again. Do they both go into the 10 times table? No. Do they both go into the 5 times table? 15 does, 6 doesn't, so I can't simplify by dividing by 5. Do they both go into the 2 times table? No, they don't. Do they both go into any other times table? And I can see again, if I look carefully, they both go into the 3 times table. So I'm going to divide the numerator and denominator by 3. So 6 divided by 3 is 2, and 15 divided by 3 is 5. Here again, I check now, can I go from 5 to 100? And I can see that I can. So what have I done to get from 5 to 100? I've multiplied by 20. Whatever I do to the bottom, I do to the top. So now I've got 2 times 20, which will give me 40. So now I can see that 18 45ths is the same as 40 hundredths. Now that I've got that denominator of 100, I can quickly convert it to a percentage. And I know now that 18 45ths is the same as 40%. So now it's your turn, and I want you to have a go at converting these fractions into percentages. And again, we'll start by looking at number 1, and I'll start you off with this one. We know we've got 12 30ths, and I want to see, can I convert that into hundredths? And I can see actually, no, I can't convert it to hundredths straight away. So I know now that I have to simplify. So I go through my questions now, don't I? Do they go into the 10 times table? Do they go? No, they don't. 30 does, 12 doesn't. Do they both go into the 5 times table? 30 does, but 12 doesn't. Do they both go into the 2 times table? Oh yes, they do. So 12 divided by 2 is 6. 30 divided by 2 is 15. Can I go from 15 to 100? No, I can't. So now I'm going to have to simplify it again. So I'm going to leave you to finish that question and answer questions 2, 3 and 4. So pause the video now, so you give yourself a chance to answer those questions. So you should have had a go at all of those questions now, and all of these you require to simplify before going back to the denominator of 100. So let's have a look at what your answers should have been. So from 12 30ths, we should have ended up simplifying it to 4 tenths. which then is the equivalent fraction of 40 over 100, because remember, we want to get to a denominator of 100 if we are converting from a fraction to a percentage, and 40 over 100 is the same as 40%. 28 40ths simplifies to 14 20ths. We then multiply the top, the numerator, and the bottom, the denominator, by 5 to get to 70 hundredths, and we know if it's out of 100 we can just write percent, so 70%. Number 3, 12 15ths, we could have simplified to 4 fifths. We can see that we are multiplying both here by 20 to get to 80 out of 100, which is equal to 80%. And finally, number 4, 36 60ths, we can divide the numerator and the denominator by 6 to get to 6 tenths. We then can multiply the numerator and denominator by 10 to get to the denominator of 100, which remember is what we want when we are converting from a fraction to a percentage, and therefore 60 100ths is the same as 60%. Please mark your work. Right, so now what you need to do is you need to take a picture of the work that you have completed in your maths book and send that through to your class teacher. You also then need to log on to Class Dojo and complete the maths activity which has been set for today. Now that maths activity looks at what we've just been looking at, and it uses the skills that you've just learnt. So make sure you're trying to use the skills that we've just talked through on your worksheet. Remember, if you are struggling with this, me and Miss Beck are live on Microsoft Teams from 10:30 until 11 to give you the support with the maths that you might need. Please log on to Teams at this time if you need this support. If you have completed the work confidently, you've got the questions right and you've submitted that onto Class Dojo so that we've had a chance to look at it, then you do not need to log on to this session. Okay? Thank you again for your hard work today, and I will speak to you tomorrow.